Welcome to ZoomInData, your go-to channel for in-depth data engineering, analytics, and modern cloud technology interview preparation. In this video, we dive deep into the top 25 streaming analytics in Microsoft Fabric interview questions for 2025, updated as of early 2026. Perfect for data engineers, real-time architects, analysts, and anyone preparing for Fabric real-time intelligence, event streams, Lakehouse, KQL, or streaming pipeline roles. We cover continuous data processing, event time versus processing time, windowing, late data handling, low latency techniques, fault tolerance, scaling, OneLake integration, hybrid batch, streaming, security, Power BI real-time dashboards, back pressure, performance optimization, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What is streaming analytics in Fabric? Streaming analytics in Microsoft Fabric is the continuous ingestion, processing, and analysis of unbounded data streams to derive immediate insights and trigger actions with minimal latency. It leverages real-time intelligence components like event streams for ingestion, transformation, and Lakehouse for storage, querying with KQL. Enables use cases such as IoT monitoring, fraud detection, log analytics, and operational dashboards requiring sub-second to low-second response times. Seamlessly integrates with OneLake Delta format and Power BI Direct Lake for unified real-time and historical analysis. 2. How does Fabric process continuous data streams? Event streams provide no-code pipeline for ingestion, in-flight filtering, aggregation, windowing, and routing to multiple destinations. Enhanced capabilities support SQL-based transformations and derived streams for complex event processing before landing. Lakehouse continuously ingests processed events into KQL databases, enabling immediate querying with materialized views. Structured streaming in Spark Lakehouse offers code-first alternative for stateful, micro-batch, or continuous processing. 3. What sources feed streaming analytics in Fabric? Native connectors include Azure Event Hubs, IoT Hub, Fabric Workspace Events, and Kafka-compatible custom endpoints. Enhanced sources expand to Amazon Kinesis, Google Pub, Sub, Confluent Kafka, and Change data capture streams. Custom app endpoints support HTTP push or Kafka protocol from any application or third-party system. Real-Time Hub discovers and subscribes to existing streams across workspaces for centralized ingestion. 4. How does Fabric handle event time processing? KQL uses ingestion_time for processing time or custom timestamp columns for true event time windowing and ordering. Event streams preserve source timestamps, enabling accurate event time semantics in downstream KQL queries. Materialized views and session windows process based on event timestamps rather than arrival order. Watermark policies in KQL handle out-of-order events by delaying aggregation until late data threshold. 5. How does Fabric support windowing functions? Event Streams Enhanced Mode offers tumbling, hopping, and session windows with SQL operators for in-flight aggregation. KQL provides bin, make series, and window functions for time-based rolling calculations and gap filling. Materialized views continuously maintain windowed aggregates for instant query access. Structured streaming in Spark supports event time windows with watermarks and state management. 6. How does Fabric manage late arriving data? KQL watermarks delay final aggregation until specified lateness threshold, allowing updates for late events. Session windows dynamically adjust based on inactivity gaps to include delayed related events. Retention policies keep raw data available for replay and reprocessing of late arrivals. Materialized views with update policies incorporate late data incrementally without full recomputation. 7. How does Fabric ensure low latency processing? Direct ingestion modes and in-flight transformations minimize pipeline delays before data lands in EventHouse. EventHouse hot cache and columnar optimization deliver sub-second KQL queries on recent events. Materialized views pre-compute common aggregations continuously for instant availability. Dedicated real-time intelligence capacity isolates streaming workloads for consistent performance. 8. How does Fabric support real-time insights? KQL queries with live previews and visualizations provide immediate pattern detection and anomaly identification. Data Activator monitors streams and triggers actions, email, Teams, Power Automate, on defined conditions. Materialized views ensure always current metrics for operational monitoring. Integration with Power BI Direct Lake enables sub-second real-time dashboard updates. 9. How does Fabric manage fault tolerance in streaming? At least once semantics with retention up to 90 days enable replay of events after downstream failures. Geo-redundant event hubs backend and pause, resume maintain stream state during outages. Multiple destinations provide redundant routing for automatic failover. Checkpointing in Spark structured streaming ensures exactly once processing with recovery. 10. How does Fabric scale streaming workloads? Event streams throughput units scale ingestion horizontally to millions of events per second. EventHouse databases autoscale compute nodes based on concurrent queries and ingestion rates. Partitioning distributes load across shards for parallel processing. Capacity bursting handles sudden spikes without persistent over-provisioning. 11. How does Fabric manage streaming storage? EventHouse uses columnar compression with hot, cold tiering for cost-effective retention up to 90 days. Automatic extent management merges and optimizes storage segments continuously. OneLake Delta Export provides long-term archival beyond EventHouse retention. Retention policies per table, database automate data lifecycle management. 12. How does Fabric integrate streaming data with OneLake? EventHouse tables exposed as Delta Parquet files in OneLake enable zero-copy access across workloads. Routing from event streams directly to Lakehouse lands streams as append-only Delta tables. Shortcuts virtualize external streams for unified Lakehouse consumption. Power BI Direct Lake queries streamed data seamlessly alongside batch sources. 13. How does Fabric support complex event processing? Event streams enhanced SQL operators enable pattern matching, correlations, and multi-stream joins in flight. KQL supports advanced joins, unions, and machine learning functions for sophisticated pattern detection. Derived streams and materialized views build hierarchical processing pipelines. Spark structured streaming offers code-first stateful operations like map with state. 14. How does Fabric manage streaming security? Workspace RBAC and item-level permissions control ingestion and query access. Managed private endpoints restrict network traffic to approved VPCs. Row, column level security in KQL filters sensitive streaming data dynamically. Entra ID authentication with service principals secures automated pipelines. 15. How does Fabric support real-time dashboards? Power by Direct Lake on EventHouse Delta enables sub-second visual updates without refreshes. Automatic page refresh streams latest metrics to report visuals at configurable intervals. KQL queries embed custom real-time calculations directly in dashboards. Data Activator integrates alerts and conditional formatting for proactive monitoring. 16. How does Fabric integrate streaming analytics with Power BI? Direct Lake Mode queries EventHouse Delta tables for high-performance real-time semantic models. KQL Database Connector supports live connections for embedded streaming visuals. Materialized views serve as optimized sources for Power BI aggregations. Activator actions trigger notifications visualized in Power BI reports. 17. How does Fabric handle duplicate events? Idempotent transformations and upsert policies in destinations prevent duplicate impact. Deduplication in event streams using unique keys or watermarks filters repeats in flight. Exactly once semantics in supported connectors avoid source-level duplicates. KQL distinct or summarize operators handle duplicates during analysis. 18. How does Fabric manage back pressure? Throttling slows producers when downstream components lag, preventing system overload. Queuing and buffering absorb temporary ingestion spikes gracefully. Autoscaling increases resources under sustained high pressure. Monitoring alerts on backlog enable proactive capacity adjustments. 19. How does Fabric optimize streaming performance? Early filtering, projection, and aggregation in event streams reduce downstream data volume. Materialized views pre-compute expensive operations for instant query results. Batching and compression optimize transfer efficiency to EventHouse, Lakehouse. Workload isolation and dedicated capacity ensure consistent low latency. 20. How does Fabric support hybrid batch stream processing? OneLake Delta Export unifies streamed data for batch refinement in Lakehouse medallion layers. Pipelines orchestrate streaming ingestion followed by batch Spark transformations. Power by Direct Lake merges real-time streams with historical batch data seamlessly. KQL unions correlate streaming and batch tables for Lambda-like architectures. 21. How does Fabric manage streaming metadata? Dynamic schema inference adapts to evolving event structures during ingestion. Mapping policies in event streams normalize and enrich metadata before landing. Purview catalogs lineage from streams through transformations to queries. Update policies in EventHouse promote fields or add calculated columns. 22. How does Fabric handle streaming error recovery? Retention and replay capabilities reprocess failed or missed events from buffered storage. Runtime logs and error routing in event streams enable custom handling paths. Checkpointing in Spark streaming ensures resumable state post-failure. Alerts and monitoring facilitate rapid diagnosis and pipeline resumption. 23. How does Fabric manage cost for streaming workloads? Pay-for-use capacity charges only active ingestion and query time, with no idle costs after inactivity. Throughput tiers and retention tuning balance performance against expense. Autoscaling minimizes over-provisioning during variable traffic. Monitoring optimizes configurations to eliminate wasteful processing. 24. How does Fabric support enterprise streaming use cases? High-scale ingestion and querying support thousands of concurrent users in fraud, IoT, and logistics scenarios. Multi-tenant workspaces with private endpoints secure sensitive enterprise streams. Compliance features like purview auditing and retention meet regulatory requirements. Hybrid integration with batch enables sophisticated enterprise event-driven architectures. 25. What are best practices for streaming analytics in Fabric? Apply early in-flight transformations in event streams. Use materialized views heavily for common KQL aggregations. Implement watermarks, session windows, and idempotency for accurate late, out-of-order handling. Monitor backlog, latency, and errors proactively. Integrate Data Activator for automated responses. Export to OneLake Delta for long-term hybrid analysis. Govern with purview lineage and RBAC. Thank you for watching. If this video helped you prepare for your Microsoft Fabric interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth data engineering, analytics, and cloud technology interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.